The register and call nodes are powerful combinations that lets AI dynamically trigger various flows without having to hard code any specific flow. Here's what I mean. Imagine you have two automation flows for your smart home. One of the flows can turn devices on and off, so let's say this one here, and the other one can answer any question that you give it. So let's say this one here. Let's say these flows are a lot longer than just this debug. Now let's see how the register node can help make this automation a little bit more advanced. The register node has a simple and advanced mode. We will use the simple node to define a function that will answer the questions. First, we're going to give it a name, and the name represents a function, and it follows simple rules for function naming. So it can't have spaces, and it must be of a certain length. And basically the rule of thumb that I use is that I try to keep the name short but descriptive using snake or camel casing. So in this case, we have here answer question. Now, the intent description is exactly what it is. This is the description of what the function should do. I suggest making it very descriptive or descriptive enough. I suggest making it very descriptive or descriptive enough so that the LLM will know why it should be called. The better you describe it, the more consistent results you're going to get. We're going to leave this to false, and that's pretty much it. We're going to click done, and then you'd click deploy. In my case, I'll just enable this. So once you deploy, you can go back to the chat node, and then when you check the drop down, you should see it within the list. You will select it, click done, and then deploy once more. Now let's register the second function. This will be responsible for turning off and on the different devices. So we'll give it a name as normal. We'll also give it a description. But this time we're going to set advanced mode to true, and that's going to activate this tool schema section. The advanced mode is used when you need the LLM to respond back with dynamic properties. For example, our flow needs to know the name of the device and whether or not to turn it on or off. So we're going to need the LLM to dynamically return two different parameters. Now, the functions are defined using this JSON schema that you see here. And each platform has a similar schema, but they also have their peculiarities. And it's best to consult their documentation to learn how to write the schema for that platform. That's out of scope for this video, but here's a tip. You can use AI to help you create this schema. So this schema here was created by me talking to ChatGPT. I told it that I needed to create a schema or do function calling for OpenAI, and that I want the function to return an object with two parameters, entity and action. And the entities represents the device that I want to control, and action is the action that have two options on and off. And this is what it created. Now, the important thing to note is that even though this is how they define the function for OpenAI, we don't need this section here. We are only interested in parameters. That is what the node requires. So I simply copied this section here. This is all that I need. And I pasted it in here. As you can see here, this has two properties, entity and action, both of which are strings, and they both have descriptions. And for the action, you can see that it is an enum that has only two types, on and off. Let's deploy this, or in my case, I will enable it. Deploy. And go back to the chat node. And then you can see that we have this execute command now. So we'll select it. I make sure that this is set to required, so it will choose one of these two, or both. Click done. And deploy once more. Now we need this call node. The call node can also call specific nodes, so we can let it call specific things if you need a more rigid way to handle your responses. But in our case, we're going to use this dynamic mode, which is this use payload node name. This keeps everything dynamic. Now I have these two inputs here, or these inject nodes. One is going to ask a question, the other one is going to give a command. I have this template node that basically lists all of the entities and their state. So we have bathroom light is on, kitchen light is on, bedroom light is off, porch light is off. Here I have the template node that's responsible for creating the object that's going to be used within the LLM chat. So here I'm passing in the payload from the previous template node. So this is going to be the system node that has all of the static information. And then we have the user section, which is going to use the topic. And the topic is going to come from the individual inputs here. So for instance, you can see the topic here is what devices are currently on. And the topic here is turn off all devices. Let's run this to see what happens. Now we're going to ask a question, what devices are currently on, and what we expect to see is answer question fire and NC debug 212 light up. There we go. So this appropriately fired. Now let's check out this one here, turn off all devices. And there we go. And now you have it firing out. Now, because we had 4 different entities, you can see that it fired 4 times. Action, entity is off. Let's just pick another random one. Entity, bedroom light, action off. If we check this debug node and we set it to complete object, I want you to notice what comes with this information. We can see that each one comes with an index, and this allows you to dynamically choose the index within the payload for whatever function is currently running. This allows you to use it with the join node and combine things together or run things in parallel. Now this whole flow can get even more powerful as you can daisy chain chat nodes to help separate responsibilities. If you notice, when we called the question node, the LLM was only responsible for determining which function to call, and it rightly called the answer question node. But inside, you can see that there's nothing really because it doesn't define any parameters to pass back. This is where we can introduce a second chat node that is responsible for answering the question specifically.